In this episode, we catch up with David Crook, a developer evangelist at Microsoft. He is a co-organizer for the Fort Lauderdale Machine Learning User Group and is involved in many more user groups and meetups. You hear about some really cool projects where they're using Python and TensorFlow to work on simple things like growing more food to help feed the world. This is Talk Python to Me, episode 73, recorded August 25th, 2016.
I'm a developer in many senses of the word, cause I make these applications, but I also use these verbs to make this music. I construct it line by line, just like when I'm coding another software design. In both cases, it's about design patterns. Anyone can get the job done, it's the execution that matters. I have many interests, sometimes it conflicts.
Welcome to Talk Python to Me, a weekly podcast on Python, the language, the libraries, the ecosystem, and the personalities. This is your host, Michael Kennedy. Follow me on Twitter where I'm at mkennedy. Keep up with the show and listen to past episodes at talkpython.fm and follow the show on Twitter via @talkpython. This episode is brought to you by Hired and now Capital One. They both have great offers for Python developers, so please check out what they're offering when you hear their spot. It helps support the show. David, welcome to the show.
Hi, Michael. It's good to be here.
Yeah, it's great to have you here. I'm super excited to talk about all the cool machine learning and Python stuff you guys have going on over there at Microsoft and in your little area in particular. But before we get to all those stories, how did you get started in programming Python?
So Python in particular is an interesting one because I resisted it for a long time. Let me step back a bit and just start, where did I start with? My parents were like, you're going to go to college and you're going to be a programmer. And I was like, I want to be an archaeologist, not a programmer. And then they kind of said, well, we're not going to pay for college if you don't do programming. So I said, all right, I guess I'll do it. So it really got kicked off around college and I started a video game club. I did a lot of XNA programming.
That's cool. So XNA, just for people listening, XNA was like a high-level game programming environment that you could write games for both Windows and Xbox in C#, right? But it abstracted a lot of the game engine stuff, right?
Oh, yeah. Yeah. And when you're just getting started into programming, like you don't want to have to sit there and figure out how to do like different swaps with the GPU and all that kind of stuff. It was just a really good way to get into programming, throw it on your Xbox and be able to have something that's useful and like a lot your own. So, like if you were doing a lot of game mods, you were kind of stuck with whatever you had in that environment. XNA was just whatever you want to do and gave you just a high level abstraction on it. So that was a really cool start.
Awesome. So you had a group in college doing that, huh?
Yeah, I didn't really know how to code that much, so I discovered that if I surrounded myself with a bunch of people who could, then I could hopefully learn from them. So I formed a little group and basically recruited a bunch of people to teach me in the guise that I was teaching them.
How interesting. I think that's really common and really effective. I 100% agree with you that surrounding yourself with programmers is almost key to making you a programmer. You can do it just on your own, but it's really not the same experience. And I don't know very many other groups that are like that. Like, do lawyers say, hey, let's all just get together after work and just talk about law, like passionately, Like maybe
we probably have World War III.
Yeah. I mean, plumbers don't necessarily do that, right? I know plumbers have a real craft and expertise and they might have apprenticeships, but this we're so excited we want to just get together and make everybody better. It seems fairly unique to programming, and I think that's one of the reasons it's so awesome, right?
Yeah, I think there's a couple trades maybe where they do that kind of thing. Like my uncle is he's in construction and does industrial air conditioning. And I guess they have like a builders guild, but it's not nearly like what you see in the tech ecosystem where you can just like hop online and be like, I want to go to some really obscure group in my area and bam, you found it. It's like, holy cow, that exists.
Yeah, absolutely. And you actually have a big hand in those existing in Florida, which we'll get to. But I interrupted your story about moving on towards Python, but your path there?
Yeah. So I started, and it was a lot of C# development. And then, schools like, we're going to teach you this Java thing. I graduated, worked through Microsoft for a while, and then started discovering this machine learning IoT space was a really neat place to get into. And I keep seeing this Python thing pop up over and over again. I was like, oh, it's another language. I already know like 7. I don't want to know another one. Let's see how long I can put it off for. So I think I put learning Python off for about 4 years until like recently I finally broke down and said, all right, that's the last library. It's the straw on the camel's back. I better just break down and learn this thing. And so I started picking it up about 2 or 3 months ago, just kind of slowly to just explore and see. And once I kind of got in, it was like, a lot of this is really familiar. It's not really that different from anything else. Syntactically, it's a little different, but, a lot of the same kind of stuff. But I get all these other libraries and capabilities along with it. So it's been a really nice transition and a lot less painful than I thought it would be.
Yeah, I think there's a lot of myths about Python that are out there, and once you get into it, it's a little different than maybe what the preconceived notions about it might be.
I think some of the myths were like, I was challenged with a couple of them. One was like the performance thing, like, oh, Python's not performant enough or whatever. I was like, well, at the end of the day, my performance is mostly like in web, like stateless servers, or it's going to be from GPU compute. Well, it has great GPU libraries, and then okay, I don't know if Flask has the most performance, but it's a stateless web server, so I can just always throw more servers at the problem. So I'd rather just have something that does everything and reduce the number of skills I need and throw servers at it than fight with trying to learn something else.
Yeah, that's a good point. I mean, the performance story around Python is not straightforward. I think it's pretty good in a lot of areas, and there are certainly some areas where other languages, like you were coming from .NET, for example, where it is better over there. But, for example, I did a conference talk that was trying to compare working with a NoSQL schemaless database and saying should use a dynamic language or a statically typed language. And I chose C# and Python as the 2 comparison languages. And the Python web app was actually quicker end-to-end from the browser perspective than C#. So I think part of the story is the C# code surely ran faster because it's JIT compiled, right, to machine instructions. But the framework was doing less so that it actually was overall faster, which is part of that like interesting trade-off. Like you wouldn't think that it would be, but there's just so many factors that it's hard to say. So yeah, that's cool. I think most of the time it's good, but you got to just test it, right?
Yeah, as from what I've seen, most of the time it's just a shot in the dark. You don't really know what it's doing under the hood anyways. So like, you just cross your fingers and hope. And, even in the other worlds, I end up like, even in C#, eventually you're like, okay, now you need a West Coast server and an East Coast server. Oh no, we've got a bunch of people coming from Texas. Let's throw a central server in there. So you're doing it anyways. You might as well just pick what gets the job done the most with the least number of headaches. And then it ended up being Python because you get all the nice machine learning tools and you get web servers and you get desktop and the documentation is just absolutely phenomenal.
Yeah, it's a fantastic ecosystem. So before we move on to some sort of what you're up to nowadays, I did want to ask you, since you are sort of fresh to Python, what was surprisingly easy or nice about the language, and what gave you challenges? You said a little bit, but like, give me the summary of your learning experience here while it's still fresh in your mind.
Yeah, so I've got a customer project that I'm working on now. So this is like the first real, like we're going to do something production level with it. Previously, till about a couple weeks ago, it was all just dipping my toes in, and now we're going full on production level. Some of the easiest things was Flask. Like I come from ASP.NET MVC Web API background, and like Flask is basically just like that with like a different syntax. And I was like, this is phenomenally easy. Like the authentication and token stuff is all very similar. The way that you do the headers and decorators is all very similar. There's some nice things like Python doesn't really seem to care what kind of object you return. So from the same function, I can return like some ambiguous object one and some other completely different ambiguous object. And then that's really neat. I didn't think that was something that, C#, I don't know how you do that. Usually you do a wrapper with like generic types and, C#6 made that easier. But
yeah, there's so much ceremony in the static languages, right? Even the nice ones.
Yeah, so that was a really nice thing. Some of the challenges really is just kind of getting used to some of the tooling around Python. So I spent like forever trying to figure out which editors I wanted to use and how packaging worked. It took me a while to just kind of just conceptualize packages, because the way packages are in Python are very different, because it acts more like it's like a script. It's not like a compiled language. So you don't have like different projects and libraries. You have packages, which literally are just script files with initialization to it. And there's reduced ceremony in how that happens. So even with the reduced ceremony, it's just not what I was used to. So coming to it from more the statically typed and compiled language background was like just a weird transition and took a little bit of mental getting over.
Yeah, it's interesting when you're learning stuff that somewhat the challenges of learning things, programming techniques and so on, has to do with, is the thing you're learning actually hard? And the other one just has to do with your preconceived notions of how things should be done, right?
Yeah. I was trying to figure out how to stick extra libraries, and I was doing just doing all this extra abstraction that I just didn't need to do. I was like, okay, we're going to do some dependency injections so that I can swap out my back end. Because right now I'm pointed to some local files, but I want to swap out with the actual database. And right now they're on SQL, but they're probably going to go to Mongo. So I needed to figure out how to easily swap that out. And I think it ended up just being easier to not use something like dependency injection, because the abstraction in Python it wasn't quite as necessary as it was before, I guess, is what it seems to be boiling down to. I'm still working through that problem specifically, though.
Yeah, it's interesting if you look at the design patterns that typically were created, decorator, state, all these various design patterns, and you look at them for static languages, there's so much ceremony and formalization, and then you look at them in the Python world, and they're usually a couple of lines. You're like, oh, that's all? It's nice, but it's a mind shift for sure.
Yeah, there was one thing that I thought of that actually was more of a challenge. So I have a fairly hefty F# background, and I really like functional composition and pipelining. And there wasn't anything out of the box, especially with data manipulation pipelines. I wasn't finding very much out of the box for that in Python. So there's the pandas package, but it wasn't really set up so that I could kind of do functional composition easily. But using some of the decorators and kind of making up this infix thing, I'm not really sure how exactly it works. I got it to somehow work, but it gives me functional composition. It's just, instead of being out of the box, I had to kind of write it, and I had to fight with it a little bit to make it happen. And there's some magic behind the scenes that I don't fully understand, but somehow I got it to work.
Nice.
Whereas R has the dplyr and magritter packages, and F# just has it out of the box. Python, a little bit of a fight, but it works. And now I get what I wanted.
Yeah. Okay. Really nice. Really nice. You work at Microsoft doing some interesting stuff, and you said you kind of live inside the company, but also outside in a little bit of a bubble. So maybe tell us, what do you do there?
Yeah, so I'm a developer evangelist at Microsoft. And, the easiest way to think of what a developer evangelist is and does is that we spend about 50% of our time focusing on creating a healthy technology ecosystem in our area, typically focused around what we like to do. So I do IoT and machine learning. So you'll see there's a very healthy IoT machine learning ecosystem in South Florida. And then the other 50% of the time is spent working on customer engagement. So finding some really cool stuff that folks are working on in the area and just help them be successful with it. And it's interesting because we don't charge any money. We're just focused on ensuring that people are successful with our technology and getting insight from that and delivering it back to the product group. So it's very much a field position. And, that said, I don't live in Redmond. I live in South Florida. And there's a very different kind of view because I'm not like at the Microsoft office 24/7. I'm spending more time with people who are like outside of that world. Literally, I think we're about 3,000 miles away or something like that. Yeah, you have to go diagonally across the entire United States.
Yeah, that's about the maximum distance you can get in the continental United States, I think.
Yeah, that was kind of a neat thing for me. It was as far away from HQ as I can get without leaving the country. So it's a very interesting perspective because you get to see a lot of the inner workings of Microsoft without necessarily being a part of those inner workings 24/7. So it gives you a very different perspective on kind of what like outside of Microsoft is doing, and you can feed that back into Microsoft so that we can better build tools and technologies that are more aligned with what folks are doing. So if you see like, hey, this technology, whatever it is, doesn't seem to work or meet exactly the expectations because really they're doing this, it gives you the perspective to provide that insight back.
Yeah, that's cool. And we can definitely talk more about the shift in perspective at Microsoft around these types of things in a little bit. But I think it's the short version for now is it's an interesting change, and those things are way more possible than they used to be, right?
I'm calling it the Satya decade or Satya era of Satya. It's very different. I get
awesome.
to have an Android phone.
Exactly. So Satya Nadella, the new CEO, has made a lot of changes on how that works, right?
Yeah, it's very interesting. It's like he keeps using the term customer obsessed. Like he wants us to be obsessed with our customer and just focus on the customer 110%, no matter what it is, and just make sure that they can be successful with what they want to do, using what they want to use on the Microsoft platform. And it's a very different mentality shift than what used to be in place.
Yeah, absolutely. So you said you work with IoT a little bit, Internet of Things. What do you guys have going on there?
Yeah, so this has been a really big space for us lately. We have this whole IoT suite, there's primarily cloud-hosted services, but we have some on-premise offerings. But it's all about being able to pump as much data as you possibly can into the cloud and do meaningful things with it. So there's a variety of different projects that I've seen where we do this, everything from collecting telemetry from pipelines to creating intelligent teddy bears to there was a water flow analysis project and intelligent skateboards, just all sorts of cool stuff.
Yeah, that sounds really awesome. And then what does machine learning have to do with it?
A lot of that's around delivering value back through the data that you collect through IoT devices. At least my focus area is. So, if you're collecting telemetry, you have maybe pH and humidity, temperature, and you might have vibration. It's, okay, you've collected all of this information. You're streaming it all up into the cloud. But what do you do with it? And machine learning will help you recognize various patterns and attributes to that sensory data so that while the data is actually in motion in the real-time data pipeline, you can actually execute machine learning algorithms against that in-motion data and surface interesting things to be aware of. So, for example, if you see a pattern that looks kind of like, hey, there's about to be a leak in your pipeline, you can actually recognize that pattern in the data pipeline and then put a message on a data queue for like a worker role to pick up and send SMS text messages to the engineers and the executives saying, dude, your pipe's about to explode. You need to go take care of this now.
Yeah, that's really cool. So that's really different than, oh, this is just outside the parameters. But, something instead like the last 4 times we saw the pipe explode, it kind of did
It
this.
looked a lot like this.
And the machine says, that looks a lot like something I've seen before. And you didn't like it last time. Go check it out. This portion of Talk Python to Me is brought to you by Hired. Hired is the platform for top Python developer jobs. Create your profile and instantly get access to 3,500 companies who will work to compete with you. Take it from one of Hired's users who recently got a job and said, I had my first offer on Thursday, after going live on Monday, and I ended up getting 8 offers in total. I've worked with recruiters in the past, but they've always been pretty hit and miss. I tried LinkedIn, but I found Hired to be the best. I really liked knowing the salary up front. Privacy was also a huge seller for me. Sounds awesome, doesn't it? Well, wait until you hear about the sign-in bonus. Everyone who accepts a job from Hired gets a $1,000 signing bonus. And as Talk Python listeners, it gets way sweeter. Use the link hired.com/talkpython2me and Hired will double the signing bonus to $2,000. Opportunities knocking. Visit hired.com/talkpython2me and answer the door. That's cool. I've thought about that for software, right? Like Netflix actually uses machine learning to monitor their servers and their apps in production. But that seems to me like really, I don't know, really clear and cut, like what it is you're processing. But for pipes and all sorts of physical things, that's really cool.
Yeah, I really wanted to spend some time like getting out into the physical world a bit so that I could see it. Like I really want to everything that we do as software engineers is virtual all the time. And I wanted to see, is there a way to create a stronger relationship between the physical and the virtual and kind of pass information between those two worlds in a meaningful way that delivers value to our customers. And IoT and machine learning together really is a powerful way to do that. And it's neat, especially with like a lot of the stuff that's coming out. Like, I don't know if anyone watches GPU conference, but NVIDIA just came out with this RoboCup dev car. Literally, it's like a Formula One race car that's like a self-driving car platform for like Formula One race cars.
Yeah, I just did hear that they just came out with a CPU, GPU type thing for cars. That's really cool.
Yeah, it's and seeing that kind of technology come out is absolutely amazing. So that will be an example of something that's really powerful that you can stick on any number of sophisticated devices, and you will collect a lot of the information and video feeds from that device that it's computing, stream that up to the cloud so you can optimize your algorithms, your self-driving car algorithms, your image recognition, what have you. And then basically you get back a matrix of numbers, huge matrices of numbers, and you just shove that back down onto the device. And it's a really neat pipeline because I don't know, it's just so cool to see that happening.
Yeah, it is really cool to see those dedicated things. I mean, GPUs used to be just for graphics, right? But now they're for so much more. And you said you're doing some stuff with GPU wrappers, but it's been a little while since I've talked about this whole programming logic on GPUs and why you might care, but maybe give people like new listeners a quick summary. Like, why would people program GPUs over just like regular code? Like, what's this performance story there?
Yeah, so it's I'm taking a look at the Microsoft Cocos database as an example. So you can go look at this. I think it's mscocos.com, or if you just like Bing Microsoft Cocos database, you'll find it. You can Google it too. I'm sure you'll find it both ways. Anyways, it's an image recognition database that you can use, and there's a challenge out there. Anyways, what's interesting about images, especially if you're talking like 1080 by 1920, literally to get the number of features or columns that you're going to need to compute against, you multiply 1920 times 1080. That's the number of pixels. And if you have an RGB image, you have 3 channels. So now multiply that number by 3. You're upwards in the 5 million representations of an image. And each one of those pixels is potentially important.
Right. And how many frames a second, right?
Yeah. So if you're doing 60 frames a second and you have 1 second, you just generated 60 times whatever that giant freaking number was. And that's 1 second worth of information. Now, out of that, you'll probably extract a few key images and compare against that. But, at the end of the day, you're talking huge quantities of compute data. And when you think about a GPU versus a CPU, you're doing a single mathematical computation, and on a CPU you have one, so you can do one computation at a time. Maybe you have 6 CPUs and like 12 virtual processors, so maybe you can do 12. Well, on a GPU, I just built my own dev box. I've got the new Titan X. Each one of those has 3,100 processors. So on my dev box that I have about 6,000 processors. So with each one of those, I can actually do a numerical computation against each pixel literally 6,000 times more and faster than a CPU, because I have 6,000 processors instead of one.
Yeah, that's insane when you think about the parallelism differences there, right?
Yeah, so when you're thinking GPU versus CPU, it's how are you parallelizing your workload and what is it specific for? And the other things are like a GPU has its own internal memory. So each one of my GPUs has 12 gigabytes of internal memory. So I can load, because I've got 2, I can load 24 gigabytes of image data onto those. And I have them set up with the standard SLI bridge. So it's basically a super awesome video game box. One of the benefits of deep learning is you can play awesome video games on your workstation. But you load the data on and you transfer the model back and forth over the SLI bridge. And it allows you to compute so much faster because you have the onboard GPU memory, which is typically DDR5X. I don't even know. It's the one with the 5 and the X in it, as opposed to DDR4, which is just a much faster memory. So it's a more performant way to do large quantities of data that have excessive numbers of features. Whereas like you might use something like Spark if you have large quantities of data, but maybe not as much parallelism in each computation task. Like in an image, you have 1920 times 1080 times 3 number of computations per observation. Whereas like in business data, you might have upwards of 200 computations, maybe 1,000 computations per observation.
Right. That makes sense. So how do you program these GPUs? Can you do that from Python?
You can. So there's 2 libraries that I was evaluating. There's one that's made by Microsoft and there's one that's made by Google. Both are open sourced. The Microsoft one is CNTK, or Computational Network Toolkit. I don't know if the Python wrappers are available yet. They should be sometime. You have to check their Git repo. I ended up not using that one. I went the Google route. I work for Microsoft and I get to use Google Compute Graphs. It's awesome. Welcome to the Satya era. So I'm using TensorFlow. It works wonderfully on Azure. It works wonderfully on my box. So I get to use Google technology on the Microsoft platform. So that's kind of how I get to use it with work. But the neat thing about TensorFlow is that you get to use Python, and it has interactive and batch execution. So, if you're just getting started into it and you're like, I don't know how this thing works, well, pop open a console and start like having at it in interactive mode and outputting some stuff and just see what the heck happens and poke around with it. Whereas like a lot of the other compute frameworks require you're back to almost like compilation style, where you generate your full graph, then you more or less compile it and then execute it, and it shoots back really cryptic errors when something goes wrong.
I see. So like you would write it in, let's just say Python, and then compile it to like shader language or something like that. You send over to the GPU and then get the answer back?
Yeah. That's kind of how most of them work. And TensorFlow has that capability as well. The benefit to doing it that way is that you actually take full advantage of everything that it does behind the scenes for you. Whereas when you run TensorFlow in interactive mode, you're just going to thrash your performance you might as well be doing it on a CPU. But the benefit is that you can experiment and learn in interactive mode and then just swap your flag back to batch mode, and then you get all the performance goodness.
Okay, that's really awesome. Yeah, so if you're doing machine learning or just real computational stuff, right? TensorFlow sounds great.
Yeah, and it supports multi-GPU, multi-node, just really cool stuff. And I'm pretty excited. It's really expensive to buy GPUs, but now you get these rentable GPUs. So Azure just went into private preview with the N-Series, and AWS has some virtualized ones. And you can get as many nodes as you want, learn TensorFlow. And if you can't do it on your own box, just rent some GPUs. They're usually like $2 an hour or so for a GPU box on the cloud. Maybe it was $2 a minute. I can't remember if it was $2 a minute or $2 an hour.
I think it's $2 an hour. That's pretty awesome.
Yeah, really, it's helping democratize kind of scientific hyperscale computing. The cloud is just an absolutely phenomenal thing. Like, before, like my workstation, I'm lucky to have had a lot of success in my career and my life. So I can go buy like a $5,000 workstation for work. That's not necessarily possible for everybody, but in the cloud, you just go grab a GPU box for a few hours and have a script that turns it on and turns it off for you.
Yeah, that's awesome. Yeah, I mean, even if you work at a company where they would buy you a $5,000 GPU box, if you have no idea if it's actually going to solve your problem, spending $10 to find out and then buying the $5,000 machine is really a nice possibility rather than, leaping in and seeing if it's going to work and maybe it won't.
Yeah. And I think there's other benefits to having the cloud GPUs as well. Mostly that they're even faster than mine. So like I'm not terribly familiar with AWS's offering, what they have, but ours, we've got, you can get 4 of the latest ones that NVIDIA has, and that's the one that's $2 an hour and you get direct hardware access. It's like, okay, so it was $5,000 for me to get like a box with 2 GPUs, and they're not even the top of the line. They're the Titans. They're not the Kepler series. Whereas I can go and get the Kepler series and I get 4 of them and all the backing hardware at $2 an hour. It's just my mind is getting blown with what you can get and what price you can get it for.
We definitely live in a special time, don't we?
Yeah, I'm feeling a little spoiled about that.
So you talked about your career, and you said maybe it's a good time to touch on that. You said that you had a bit of a rough start in college, and the contrast between college career and professional programmer career are really different. You had some great tips there.
Yeah, so I was pretty much your typical college student. Went in and was like, I don't want to do programming. And parents were like, you're going to do programming. And it's like, okay, well, I'm going to be rebellious while I do programming. So I was pretty much throwing parties all the time and, doing all that kind of stuff. And was like, I had a super low GPA. Like, it was my senior year. My GPA was like 2.4 and you needed a 2.6 to graduate. And I was like, crap, I've got 3 years behind me with a 2.4. I need a minimum 2.6 so I can get out of here.
That's a little stressed on the last year.
Yeah, and man, I wish I had focused and took advantage of the opportunity and seeing it for what it was when I had it, but that's not what I did. So, I had to deal with that situation. So I started a bunch of groups, like, the game dev group, study groups, programming groups. I had about 3 different groups that I was managing and running to just hopefully surround myself with enough experts that I could pass. And I made straight A's the final year. I was able to get, I think, like a 2.7 GPA, which was enough to graduate college with my major.
Yeah.
And it created a really difficult hiring experience. But luckily, like, I did the interview for Microsoft and they didn't ask me what my GPA was. They wanted to ask what I did and what I liked doing. And luckily that last year of college, I was like hacking on, like, I had a motorcycle with like a performance module that you could like hack into and make your motorcycle go faster. So I hacked into that thing and like did all sorts of craziness to my motorcycle and made a bunch of video games. It was like, here's what I got. Microsoft was more interested in what I could do and not what my GPA was. So I got super lucky that they never asked that question and was able to get a job.
That's really cool. I mean, I've been in hiring roles at companies I've been at, and we almost didn't care what degree you had. If you had a PhD, it gave you a little more credibility than, a college degree, a little bit more, which gave you a little more credibility than no degree. But it really was, what can you do? What have you done? Do you have proof of that? And I think that's also pretty neat about programming.
Yeah, that was actually, Microsoft was the first company I interviewed with that was like that. The issue I had was getting just into the first interview. You submit your resume and they have like these processors that go and say, not 3.0, not 3.0, not 3.0, not 3.0. So you never even got the phone call. Like, actually, it was a developer evangelist who showed up at my school. I just talked their ear off and gave him my resume and was like, just read it, just shove it. I don't care. Just do something with it. Make sure you call me. I don't care. And that happened. Whereas a lot of the ones where I was applying online, I didn't make it past that automatic filter. There's a lot of like, you get however many students graduating out of college, you got to process it through it somehow autonomously. So I think that's what they did.
Yeah, that definitely makes sense. Well, very cool. And since you got to Microsoft, you said your career's really accelerated. You had some process to make that happen. You want to share it?
Yeah. So I think the big thing was I had this kind of oh shit moment in college, and now I'm out. I actually got married, and it was like, now I've got a family, and failure's not really an option at that point. I had to come up with a process and a method to kind of ensure I was successful and never encountered like that you're on the edge of failure scenario ever again. That's like the scariest place to be. And so a lot of it boiled down to focusing and working really, really hard on specific areas and building a community around those areas that I was actively engaged in, which is kind of abstract, but I'll give you a consensus. When I first joined Microsoft, I came in as a consultant doing development operations, and I didn't know the first thing about it. So I went to a local user group, which is a .NET user group, and started talking about TFS and application lifecycle management and source control and best practices, and built a group up. We got to a few hundred there, and it was once a month, sometimes twice a month, meeting with other professionals in the area to really zero in on this one specific thing. The main thing I learned was that, like, if you were to be successful, a lot of people can do different things very poorly, but very few can do one thing extremely, extremely well. So if you want to be the one who gets the phone call, you want to be the best of the best of the best. Of course, you're going to pass up opportunities, but you're going to be the one who gets the most opportunities in that specific area. And if you look at programming, there's so much opportunity out there that it's better to be the one that everybody thinks of. Oh, I need to do like this type of server. Let's call David. So once I kind of understood that, focus on that very specific thing and be the best in like North Carolina at it, that's when it kind of clicked, and I started seeing a lot of success in my career, because servers would go down, as they always do, and they have to call somebody, and it could be a critical scenario. So who do they call? Do they call the guy who's like a web developer, DevOps, TFS, open source, big data guy? Or do they call the person who is the best in class at that one type of server? So I actually saw a significant increase in my billable hours being utilized once I focused. And a lot of that was enabled by focusing on the community and trying to see success with that community and growing it into myself.
That's really awesome. I totally agree with you that specialization is key. I mean, you need to have enough broad skill that you can get along with general situations, but there needs to be a thing that is your specialty. Right. And if you can pull that off, you can really, like you said, you get the invitations for the conference talk. You get the call when people need help. When people Google something, they find you. It unlocks opportunity. And that doesn't need to be a broad specialty. It could be something fairly niche.
Yeah, like if you're the best dude at charting or the best girl at charting, like who are they going to call for charting? How many charts do people need to draw? Like millions of charts. There's charts being drawn all the time. So if you're just the best charter in the world, you'll do very successfully. And I think you honed in on something that was really interesting, Mike, was I called it the integration points. So it became more apparent that I had to learn my integration points as I started moving over to data and machine learning, was that I could do machine learning and be the best at machine learning, but unless I knew how to surface those capabilities into a web server or onto a physical device, I was still kind of useless. I needed to know like my specialty and like 3 or 4 ways to expose my specialty to other people that was useful. So like the microservices phenomena has become a really impactful thing, because now it's like machine learning Flask, wrap it in an API, ship it up to the cloud. Anybody can use it. That's integration point one.
Yeah, absolutely. That's a really great point. I had John Sonmez on episode 71 talking about specialization and niches, and he often talks about T-shaped knowledge. You've got some broad base, like you can set up a web server, you can create a basic web page, you can talk to a database, but then you've got some vertical deep slice that is like the reason people call you. Right. And I think that's a great way to think of careers.
Yeah, that was actually when I came into Microsoft Consulting Services. That was the first thing they said, is that here's what the T model is. Here's what your specialization is. Here's everything that surrounds that specialization. Know it or die. It's like, okay.
Okay, I'm listening. Capital One has a special message for you. They need Python pros who love to work with data. Put your Python experience to work at Capital One and help them use data to make life better for millions of customers. Capital One is employing the latest tools and approaches to do data analytics and data science from the ground up. Their smart, creative professionals love to explore new ways to interact with data. They're interested in figuring out novel, advanced Python techniques, and even more interested in finding more people who will help them do that. When you join their state-of-the-art Python community, you'll work with people you really like, people who might be listening to this podcast right now. Relentless innovation is their way of life. Make it yours at Capital One. Visit jobs.capitalone.com/talkpython to learn more and apply today. Awesome. One of the things you said that really helped you get into that position was surrounding yourself with people. And we talked briefly about some of the user groups that you've been part of. You've got a long history of creating and setting up and facilitating user groups, and you have some going now. Let's talk about that a little bit. Give us the history first.
Yeah, it started back in college, like I said, starting the video game group. And then when I got into Microsoft, creating other community groups. I've always been a field role at Microsoft, so I've never really been able to surround myself with other Microsoft people. So I had to come up with more creative ways to gain that knowledge and that expertise. And, all the different big companies have things like MVPs, which most valued professionals, or some sort of like honorary role for you're not part of the company, but you're super awesome. Right. So we're going to give you a lot of special privileges.
Like MongoDB has Mongo Masters. Google has their equivalent. You guys have your MVPs and so on, right?
Yeah. So you find those guys and you really just surround yourself with them. And then you invite other people in and you create a very open ecosystem. So I started joining a very successful one in North Carolina, the TriNUG, the Triangle.net user group, and the Research Triangle Park Data Analyst user group. Two very large groups in North Carolina, and really got me going and understanding how a professional group is run and operated. They've got memberships in excess of like 1,500 per group now of some of the best scientists in Research Triangle Park. So kind of after my tenure there for a couple of years learning how that is, I transitioned to this developer evangelism role where now one of my primary jobs was to lead and facilitate and grow groups of that nature. So then I moved down to Florida. And there are some really strong groups in Florida already, but maybe not specifically in the areas that I'm going. At this point, I've already transitioned to a lot of data science, and I was doing a lot of F# and stuff. Now I'm trying to do Python and TensorFlow. There's like 3 or 5 groups here that I'm really focusing on. There's the Fort Lauderdale Machine Learning User Group, Miami Data Scientists. There's FLA.net, Gold Coast User Group, Code for Fort Lauderdale. I'm actually speaking there tonight. Code for Miami, just a variety of groups. And what's interesting is that you can, each group has its own different specialization. So like Fort Lauderdale Machine Learning is all basically Python, TensorFlow, machine learning, and they have a fair amount of R in there as well. FLA.net is all like .net and like, Node.js. Miami is all JavaScript.
Yeah, excellent. And you said that you had a pretty interesting format or style for your Fort Lauderdale machine learning user group?
Yeah, we just experimented with this a couple weeks ago. I've done a couple of these before at other user groups and seen some success, but I call it an open forum. And basically, it's a semi-structured user group. A lot of what I see at other user groups is very presentation, lecture-oriented. You go in, somebody talks at you for a while, and then you network for 20 minutes or so, and then you leave. But this is a very different take. Everything that I've seen for how I get successful or see other people get successful is that they have hands-on experience. So we've created a semi-structured event that happens every other week where we have a 3-hour block where everybody shows up and we talk about high level, what are people struggling with? What's the direction that you've seen over the past 2 weeks? Anything interesting you want to talk about? And we do about 20, 30 minutes of that. And then we spend about 2.5 hours or 2 hours actually hands-on solving problems. So right now we've broken out into groups to try to win Kaggle or the Microsoft Cocos image recognition challenge. And what's neat is that you see a natural tendency where people share their knowledge and form into groups and are actively pursuing knowledge and actively using the tools and solving problems. So, you can go into a presentation on how to do data pipelining or how to ensure that your GPU kernel is always awake. Or you can say, here's a giant database of images with labels for the next 3 hours over the next 3 months. We're actually going to get an accuracy of 90%. And what's neat is that nobody has to even know how to do it. So when you have a lecture style group, you're forced into this thing where you have to have an expert. If you do an open forum, nobody has to be an expert because everybody's learning. Nobody even, you have to have a general idea of where you want to go, but you don't actually need an expert because you're actively coding and you're going to surface these issues and you're going to naturally solve them. That said, we do have experts around because people do this for a living. So that's really beneficial. And you see, we had a couple Docker experts, we had some Python experts and some TensorFlow experts. And, some people knew TensorFlow and Python, but didn't know how to use the GPUs in the cloud. So the Docker people come over and are like, I can help you with that. Can you show me a little bit about this TensorFlow stuff that you're doing? Because the Docker experts don't know about TensorFlow. So you get this really cool cross collaboration of skill sets.
Yeah, that's really great. And, for those who are not familiar with Kaggle sets up periodic data science competitions, and they're probably the best known out there for that. And so I think it's fantastic that you guys are like, the goal of this user group is to win Kaggle. Because when people come back and they try to get a job or a raise or whatever, they say, well, what experience do you have? Well, I placed this level in Kaggle and here's how we solved it. And it's super concrete rather than I sat through 4 talks on data science. I'm really ready.
Yeah. And because when you do interviews, it's, like we were talking at the beginning, it's what have you done? What can you do for me? Where's the proof? Well, I'm second place on Kaggle kind of speaks for itself, right? Here you go. How much money do you want?
Exactly. That's when people start calling you rather than when you call people. And of course, just like being a specialist, having people call you, it puts you in a much better position to get the job.
Yeah. And, the other neat thing to mention about this particular user group is we actually partner with a couple local recruiting firms. So what's neat is the recruiting firms have jobs available and they'll send the recruiters in. They actually provide food. They give us prizes. So last time they ordered a bunch of really fancy pizza, not like the typical nasty stuff, but really good pizza. And they had Amazon gift cards and we had about 50 people show up. And at the end, they said, okay, by the way, we've got 3 jobs in Python, we got 2 jobs in Java, a couple .NET, and 1 data science position. Come up and let us know if you're interested in any of these jobs. And not only are you growing your skills, because we've placed these events in partnership with recruiting firms, you get to learn your skills, apply your skills, and then hopefully go get a job with those same exact skills. And the recruiters know who you are, what you're doing, if you're showing up, and they'll vouch for you.
Yeah, a really excellent combination there. So with all this community building and stuff, you had some funny stories about the challenges of building community. One of them involved office hours. You want to tell us that?
Yeah, so office hours, I run office hours in downtown Miami every week on Fridays, and you can get some really incredible people and things to show up at your door. And then conversely, you could get some really crazy people to show up too. So we've done a lot of stuff about like the goodness. So we can mention a few of the crazy ones. So I'm not going to mention any names or events or anything like that. But, when I post my office hours, I post them up on Meetup, and it says machine learning office hours, Microsoft developer Evangelist will be present, free, no charge kind of thing. So this one day, this individual shows up just like, I don't know, just to harass me about stuff like Google, I guess. She's like, I really like Google, but I said, this individual was like, I really like Google, but like Microsoft kind of sucks. And like, I really want to get a job with Google. Can you like get me a job with Google? I was like, look, I work for Microsoft. I can't get you a job at Google. If you want to get a job, I can give you some directions. She's like, great, but I don't want to like code or anything. Can you like do this? I was like, oh my God. And I'm sitting there in my head, like staring at her, wondering how long I can let her talk until just she disappears. and it must have been 2 hours. It was an interesting experiment to see how long I could just
go along,
sit there. Nobody else showed up that day. So it wasn't like I had anything better to do, but it was just an example of some of the craziness that you'll get. And you'll get all sorts of different people showing up that are like that. We've had people come in and like start throwing things, but there's not too many of those. But when it happens, you're like, you can tell as soon as that person walks in the door. There's like, I don't know, you can just like smell it or something at this point. And you just like clap your hands and like rub them together and you're like, all right, let's get this going.
Let's do this.
Yeah, it's an interesting experience. But then you have other things some of the amazing innovations that have come through the door just blow your mind. There's this one individual who came in and he lost his job. And he's an older fellow. I'm not sure. I'd probably place him probably in his 60s. But anyways, he lost his job and decided, whatever, I'm not going to let that get me down. So I'm going to start a company. So he starts this company around like executive financial planning and just total ninja style builds this incredible platform for every wild thing that you could ever imagine that you'd want to do as an executive planning financials for your global organization. Like he came from a really, really large company. So he kind of knew how money moved around and what you had to do because he was the programmer for those tools. And he basically rebuilt this huge platform and you could just attach anything to it and it would do planning. I'll give you some insight. Some of the planning that it would do would be things like I have my primary workforce is in the United States, but my primary sales are in China. I need to pay my workforce, but every quarter it seems like the Chinese currency keeps dropping, which decreases the value of my stock by this much. So if I transfer my money in via these 3 ways, this is how much money I lose. Then I'm going to get impacted with the bringing my money into the United States tax. Well, here's a more creative solution around that reduces the impact on your ability to pay your U.S. workers. Okay, well, now we've generated some debt in the U.S. We still have the money in China because we didn't move it over that intelligently. How do we transfer the debt over to China via some back methods so that I can then pay off my debt in China as opposed to paying it off in the United States? And it has this whole predictive aspect of wow. Everything you could ever imagine from a perspective that just blows your mind.
How interesting. Yeah, so that guy just walks in and says, look, I built this, help me. Very cool.
Yeah, he walked in and was like, what can I do? I built this. I don't know what to do with it now. And I was like, you know what? Let me just shop this around, see what's going on. We might need to make it look a little prettier. It was much more focused on the abilities as opposed to the prettiness. But it looks like it's going to go somewhere.
Yeah, nice.
Just something of that magnitude is just absolutely phenomenal.
Yeah, that's really cool to be able to help people like that. So, David, we're getting kind of short on time. There's a few things I do want to still touch on. So let me ask you about the state of Python and machine learning and stuff in Azure, because that's something you guys have actually been pushing pretty seriously lately.
With the onset of Satya and kind of a lot of the folks in my position, we have other evangelists. A lot of us have started transitioning to Python. There's more than just me out there doing this. And we're seeing that, Python currently is the number 5 language in the world. And if you look at it, the top 3 are like C and C++. Well, those are basically the same. And then there's Java and C#. So then you've got Python after that. So we're seeing a huge need for enabling Python on our platform. So actually, I think every single one of our platform as a service offerings on Azure are, in fact, Python enabled. So my current workload is Python and Azure. So I'm deploying web applications to Azure with Flask. And there's things like Azure Functions, which is analogous to AWS's Lambda. And that's all Python enabled. Everything has a Python API. And it's just it seems to be working really well. And there's a lot of interesting things that you can do as well, because everything has a Python API. So if you want to deploy a series of servers and get the state of your servers and do really interesting distributed compute, or even stateful stateless, it's a crazy concept. There's this thing called Service Fabric. It's a stateful stateless service that helps you do distributed computation in a stateless /state, like distributed fabric kind of fashion.
I see. So like as a whole, it's stateful, but any individual piece is stateless, something like that?
Exactly. And it distributes your compute across n number of nodes. And it's super cutting edge. Like nobody else has anything like this right now. And it is, first thing they came out with was C#. Next up is Python. It's like, that's really cool to see, like the priority seems to be, and you have to balance this with I'm inside outside, right? Like I don't actually get to see what's on the backlog. I just get to look at what is coming out and what order the tools are coming out. But if you look at Azure, it seems to be C# and then either JavaScript or Python. It's going to be kind of in that order. And they're going back and forth between, well, do we support JavaScript first or do we just support Python first? Because some of the tools will come out with JavaScript or Node first, and then others will come out with Python first. And it's a very interesting perspective to see that those are key priorities. Yeah. And the cognitive services. I forgot about the cognitive services. Just there's a whole host of APIs out there on Azure that are focused on data science that are basically prepackaged solutions that are all Python enabled, and like Jupyter Notebooks as a service and just tons of Python stuff.
Oh, that's really awesome. Yeah, the whole bot framework that you guys are coming out with also looks pretty interesting as well.
Oh yeah, I can't wait to kind of get my hands on that. Like there's a big focus on natural language processing, and bots are a part of that. So like you'll see that, especially if you're using Python, you get a lot of like ad hoc power that you don't normally get, because you get things like scikit-learn, and then you get to put that in things like Azure Machine Learning, which is our democratized drag and drop machine learning toolkit. But if you're good with like Python, scikit-learn, you use the bot framework, and we have something called LUIS, the Language Understanding Intelligence Services. You can make combinations of these prepackaged solutions and then throw some semi-custom to fully custom stuff into the Azure Machine Learning as like a microservice. And the powerful offerings that you can develop as a consumer of Microsoft services. So like you would consume the Microsoft services to create value for a customer, but you can create that value super fast. Like I had to do a pre-sales engagement where I had to develop a Slack bot that could respond to random queries about a specific customer's product offerings. I had 48 hours to build this thing from scratch. And it also had to handle speech to text and text to speech. Out the door in less than 48 hours because of the ability to take advantage of those prepackaged solutions and throw a little scikit-learn in there where needed.
Oh, that's awesome. Yeah, very, very cool. What you guys got going on there is great. So I think we have time for one more thing that I wanted to touch on. And you said you're working on a project with autonomous farming. Can you talk about that?
Yeah, so I'm not allowed to talk about it too much because it's just now going under development. But the details that I'm allowed to share is another one of those tight timelines. You're working with folks who aren't necessarily experts in IoT and machine learning, and you have very high value crops in like huge quantities. And there will be things like the state of the environment will change throughout the night, and you need to autonomously deal with that because you might have one farmer or one farmhand for every 100 acres or so. And if something terrible happens, like the pH levels go completely out of bounds, well, your farmer might be 100 acres away, and now he has to ride his bicycle or his golf cart all the way over there. And by that point, if it's a super young plant, you might be in trouble. So having the ability to create what I call command and control systems, you were able to kind of extract information out of the sensors that you have, figure out what the state of that system is, and then send messages not just down via text message to the farmer, but down to like an Arduino-like device and actuate motor controls, valves, et cetera, and it can actually impact and resolve the system and put it back into a stable state autonomously. And farming is one area that we're seeing is a very interesting place. And again, a lot of that gets enabled, the tight timelines and data consolidation. They have data from all over the place. You can just throw it all up into cloud-based storage in Azure, build your models, and then surface the actual generated algorithms either on device, edge devices, or in the cloud, depending on what you need to do.
That's really cool. That sounds like a fun project.
It's probably one of my favorites. If we touch base again, probably around March, there will be a lot more details that I can share on probably about 3 or 4 projects that we have going on of similar just neatness.
Nice. Awesome. It sounds very exciting. So David, I think we'll have to leave it there. Let me hit you with a couple of questions before I let you go, of course. There's over 80,000 packages on PyPI you can grab and create autonomous farms from, or various other things, right? So what one's your favorite, or have you found really useful you want to tell people about?
Pip install TensorFlow. I mean, for some of the large scale stuff that I'm doing and some of the neat things that you can do with it, you can pip install TensorFlow. So I'd say that's it.
Oh, that's awesome. Yeah. Very, very cool. And editor, what one do you use?
I actually have to split it. There's 2 editors that I use. I use PyCharm for a lot of the Flask development and like what I'll call productionifying my code. And then I actually use Continuum Analytics Spider 3 or Spider 2. The command is Spider 3 because I find that for doing interactive visualizations and experimentation, it's really nice. So I'll write a lot of my code in Spider and figure out my algorithms, and then I'll copy paste it into PyCharm.
Oh, that's awesome. Yeah, I can definitely second both of those. That's great. All right, you got one final call to action for everybody.
I'd say check out the Python capabilities on Azure. Like the power that the cloud can bring to the table at the cost that it brings is mind-boggling. So that's just definitely something to take a look at.
Oh, yeah. Very cool. All right. It's been a great conversation, David. Thanks for being on the show.
Thank you, Michael.
You bet.
Have a good one.
Bye. This has been another episode of Talk Python to Me. Today's guest has been David Crook, and this episode has been sponsored by Hired and Capital One. Thank you both for supporting the show. Hired wants to help you find your next big thing. Visit hired.com/talkpython to get 5 or more offers with salary and equity presented right up front and a special listener signing bonus of $2,000. Are you a data scientist or Python developer who loves data? If you're looking for a place to work on data science with truly big data that can affect millions of lives, then head on over to jobs.capitalone.com/talkpython and check out the wide range of jobs that Capital One is trying to fill right now. Are you or a colleague trying to learn Python? Have you tried books and videos that just left you bored by covering topics point by point? Well, check out my online course, Python Jumpstart by Building 10 Apps at talkpython.fm/course to experience a more engaging way to learn Python. And if you're looking for something a little more advanced, try my Write Pythonic Code course at talkpython.fm/Pythonic. You can find the links from this episode at talkpython.fm/episodes/show/73. Be sure to subscribe to the show. Open your favorite podcatcher and search for Python. We should be right at the top. You can also find the iTunes feed at /iTunes, Google Play feed at /play, and direct RSS feed at /RSS on talkpython.fm. Our theme music is Developers, Developers, Developers by Corey Smith, who goes by Smix. Corey just recently started selling his tracks on iTunes, so I recommend you check it out at talkpython.fm/music. You can browse his tracks he has for sale on iTunes and listen to the full-length version of the theme song. This is your host, Michael Kennedy. Thanks so much for listening. I really appreciate it. Smix, let's get out of here.
Stating with my voice, there's no norm that I can feel within. Haven't been sleeping, I've been using lots of rest. I'll pass the mic back to who rocked it best. Developers, developers, developers.